Hey, good morning, everyone. Welcome to the second talk of the day here at Forward CloudSec. For this talk, we have a remote speaker to present for you, but first, we would like to, again, thank all of our sponsors who make this event possible. In particular, we'd like to thank our bronze sponsor, Chaser Systems. So go say hi to them out in the booth. All right, so our next talk is, what do you mean, resource not found, demystifying GCP error codes for IR and detections, by Gavriel Fried. So please give a round of applause.
Hello everyone, and welcome to What Do You Mean Resource Not Found, where today we'll talk about GCP error codes, understanding them, and how we could use them in incident response and detections. So some of us, most of us, or part of us, might have been in this situation, right? You cleared out your XDRs, your SIMs, or whatever system you have, and you remove the critical, the high, and the medium alerts, right? You're left just with the infos. But what if there's a firestorm of errors happening behind the scenes, attackers mapping their way through these failures, right? We usually focus on positive actions to detect and investigate. But what if we could have stopped or detect this attack before it happened via error codes? Or if we're building a timeline for an incident response, find out when things actually started happening. To do this, it's critical for us to understand GCP error codes. So today, I'd like to talk about errors and how in a different context, they could be an early warning for something that might happen. We'll talk about protocols and error objects. What is an error object? What is gRPC and why is it relevant? We'll talk for a second about long operations and missed identities. And finally, we'll look at some practical examples of how we could utilize error codes for detections and incident response. My name is Gavriel Fried. I'm a principal security researcher at Mitiga. I have over 10 years in cybersecurity. This is my second time talking at CloudSec, and I really appreciate the remote option and super excited. And I'm a whiskey dude, now also rum rookie, so good luck for me with that. Okay, let's start talking about errors, right? We have them in our environments all the time. You mistyped a resource name and it's not found, you're missing IAM permissions and you can't access anything, or someone overexhausted a service, right? But what if we take our assumptions of what these errors are and look at them differently? What if instead of a user mistake for a path, we see multiple resource not found on different random bucket names in a short amount of time? Could this be an enumeration script using a dictionary to map out our resources? What about IAM roles, right? Let's say we had a service account that never failed, right? It was running automatically, things were good and impersonated, but now we see this specific service account is failing on multiple different services. Could this indicate maybe someone stole the service account key and is probing their permissions? Or if we can't create a VM anymore because some zone or service exhausted, right? Would this maybe indicate someone using it for cryptojacking and they completely filled out our zone with high expensive machines? I don't know, but if we think about it in this way, we might see different context to errors. So now let's learn about these protocols and the error objects. To start, we'll need to talk about something called gRPC and AIP 193. Before 2015, Google needed a specific protocol that will be efficient, reliable, and fast for their backend and microservices. So they came up with something called Stubby, which is based on something called a protobuf and HTTP2. A protobuf serializes data into binary format, making things super small, chunky, and fast. And HTTP2 allows multiple channels on one connection, making this reliable and fast. But around 2015, Google takes their internal Stubby and make an open source version called gRPC. In 2016, it's GA for Cloud PubSub. And in 2018, we have something called AIP 193. AIP stands for API Improvement Program, and 193 is the one talking about standardizing error codes. Imagine we have multiple different services, and each one reports a different error in a different way. How could you make these systems work together? You have to have one concise standard. And in 2020, there's enhancements to something called error info, which is a section within the details of an error code. And today we're talking about gRPC and the implementation of AAP 193 in GCP audit logs. But we might think, Gavriel, why are we even mentioning gRPC? So when I was looking at error codes in GCP audit logs, I noticed they were very similar to the gRPC error codes. So I was trying to understand, where does gRPC come in a general request to GCP? So my understanding is we have our client. Our client sends the API request to something called the Google frontend, the GFE. This is where we have Google's reverse proxy, DDoS protection, and the load balancing, right? Then the GFE encrypts this information using ALTS, which is like a mutual auth TLS implementation by Google. And then the internal services talk using gRPC or Stubby. And here we understand that if they're using gRPC or Stubby for their communication, their errors are logged based on this AIP 193 standard. And that is where it ties in. So now that we understand gRPC's connection, let's see how we define an error code in GCP. An error code in GCP has three sections. We have the code, the message, and the details. The code is a canonical number, right? Usually 0 to 16. And it will tell us like 0 okay, 5 not found, 7 permission denied, etc. We also have the message, which is a human readable text, more developer friendly for their debugging reasons, but I've noticed some services don't force you to have this message. Also, in general, different services, I'm assuming, were written by different times and different people, so the structure is still there, but not all of them are populated. And the detail section. The detail section is our treasure chest. This will contain something called the error info and extra information. Now let's look at some examples of these types of errors. We could see here, for example, we have a code 3 that says that this network endpoint group resource is already being used by a different backend service. Pretty understandable, but we could see what was affected on what. If we look at this, code number 6, it says that this specific firewall already exists. Now, I've noticed that some offensive tools, when they try to abuse certain resources, once they have credentials, they try to create resources with the same name, sometime unless someone changes them. So a different thought we could have on this, for example, could be, if I see multiple already exists, could this be an abusive tool trying to abuse something here? It's something to think about, right? Code 5, we see a specific resource wasn't found. And code 7, a user wasn't authorized to perform this. But as I said, different services have different ways to explain things. Look at this code 7. We see the exact permission. Now, assume you're needing this for an investigation and you find out exactly what an attacker needed, and maybe you're now going to look if they gave themselves or assigned themselves these permissions. Or if an attacker sees this, they know what they're missing. We could see how looking for the code and the message could give us more context. So now let's move on to the detail section that gives us a bit more information. The detail is built at a type, domain, and reason. The type will usually write protobuf or error info. I'm assuming these are based on before the enhancement or after. The domain will give us the section in GCP, which is relevant. For example, we could have compute, storage, service usage, etc. And the reason will give us a text of why something happened. The big difference is that if we look from above, the error code tells us the what. The error info will give us usually a how, what, and when, like a bit more information, less of the when. So now let's look at an example here. Here we see a code 6 where the message says an IP was used by another resource, but the details will tell us which IP. Now this could be good for an investigation if we're trying to see if someone is abusing a specific IP that later on we saw, and more. Error code 5, we see resource not found, but the details tells us the resource name, the type, and the scope. A lot of useful information here, right? And error code 8. Now here's a classic case of the error info. We could see we have the domain as compute, the metadata gives us a lot of information, and we have a reason here, which is resource availability. Now think if you're writing a detection or an IR playbook, you could say, I'm only interested in looking at specific domains for errors or specific reasons, right? If we could parse this right in the right way, we could have better incident response and better detections. Let's look at this error code 8. It says that our zone resource pool was exhausted, what we mentioned earlier, right? And the details gives us a lot of information, and the message also gives us the context we mentioned before, right? We can create a VM on this specific zone because this zone is exhausted, right? Like we said, if we think about it differently. Cryptojacking? I don't know. And lastly, let's look at this code 7. If we're just going to see, okay, message says multiple permissions, so they were trying to get all these things. But we could see this error info tells us that it's service usage and the auth permission denied. So connecting this with the message, we could actually see the attacker was trying to enable multiple services and not trying to do a different action. What are they trying to enable? What are they trying to abuse? But now we could parse based on this error. Now, a question to all of you before I move on. Aren't these errors kind of similar to, I don't know, HTTP status codes? Yes, they are. We could map most of them to HTTP status codes. And why am I saying this? Let's say you might have a specific playbook or incident response technique or detection based on HTTP error codes. We could map them out to gRPC error codes. For example, the 0 to the 200, the 5 to the 404, 7 to 403, and even more here, right? We have the internal, the 13 to the 500, and 16 to 401. Now, if you could use this mapping to teach yourself more about gRPC error codes and improve your detections, this is great, and we could do it. So what did we learn in this section so far? We learned that gRPC runs behind the scenes in GCP services. We learned that we have a code with 3 sections. We learned about the details that has 3 main sections which interest us. And we learned that we could map these out to HTTP status codes. So now I'd like to talk about a special case with long operations. What is a long operation, right? Long operations are operations that could last minutes to hours. Think about builds, big exports, right? You're creating big like VMs, networks, all these different things. Think similar to Azure when you're creating a VM or you have something and you have the started, running, and end. That's kind of like a similar long operation. Now, these operations probe their status through a specific tracking ID, which is called the operation ID. Now, we might think, why am I even mentioning this? So, I've noticed when looking at the GCP error codes that cases where it wasn't anonymous GCE or GKE internal IPs, which kind of relates to last year's talk, we have cases where our principal email is null. Basically, we're looking for the user that initiated the operation and failed here, and it's not in the logs. What I noticed is that in long operations, we could tie this based on the operation ID. In long operations, we have a section called the operation, right? This will contain an operation ID, basically what we were probing the status for, and this is a unique tying point. The producer, which is the service, a first and a last. Mainly, is this the first operation starting and triggering this long operation or the last? Naturally, if we have an error, this will be the last. So the way I noticed that we could find this principal email is tied based on the operation ID, where the first is true. This way, if we're investigating an error that comes from a long operation, we could trace back the initiating user. And that is our little section on long operations with error codes. But now let's get a bit more practical, right? I would like to talk about 3 examples, right? We'll take them in PySpark pseudocode. We'll come up with an idea, see how we could create naive detections, and then a bit more specific detections using context and our error codes. Let's see if we could find reconnaissance, right? We're looking for the multiple, someone's looking for multiple resources, right? But if we don't classify which error code, Typos could also be part of these errors, and we'll need a bit more context. Let's see what I mean. If we have like a naive detection, super naive here, right? We're saying the status code isn't 0, basically any error. We are looking for a specific IP with over 15 errors in 30 minutes. This could cause multiple false positives, and it has 0 incident response context. Why are these errors here? Are they automatic? Are there an issue? This is too naive. But what if we say, you know what, we're only looking for resource not found, and then we're going to look for a minimum amount of specific assets that weren't found based on the user, the email, and the project. And here we're also adding some, score based on how broad this scan is. This is much more specific to the context of what resource wasn't found. We're looking for a specific attack case here of probing. Let's look at some of the stats we have here that we could clearly see this good detection yields way less results, right? And we reduced all these false positives and got to a point of 2.04%. Now you might say that was way too broad because we looked for any errors. And I agree with you, which is why we'll move on to the next example. In our next example, I'd like to talk about misconfigurations versus malicious operations. Let's assume an attacker found multiple service account keys, and they want to target a specific service, and they're trying to probe which service account has access to this service. Now, if we just look for permission denied, and we'll have disabled APIs, which also, when we have a disabled API or a service unavailable, it will be sometimes under permission denied, we could lose the actual attack. So how do we differentiate, right? A naive approach would be any permission denied for a specific account, let's say here over 20 and 15 minutes, right? None of these are production ready, but these are just like thoughts of how we could approach this. This could be too noisy. And again, we don't have any context for incident response or what they failed to get. But what if we say, okay, if it was a service disabled only for one account, this might be a misconfiguration, right? Someone wrote something wrong. But what if we say we have multiple callers for the same API and same reason we're extracting from the error info in a short amount of time? Could this indicate this case of probing different accounts to attack a specific service? This one gives us much more context and much more being much more specific about this subject. Here, we see we only found 6 alert on one of the environments, and the rest couldn't find anything. Now, again, this isn't production ready, but we could see how playing around with specific context, right, of what we're looking for, using the error info if we can, and different usages of our error codes could yield much better results. For our final example, I'd like to talk about a case we mentioned. A user found a service account key and they're trying to probe their permissions. Again, if we just look for permission denied, we could have multiple cases of false positives and no context. A naive approach here would be pretty similar, 30 denials for a specific user from an IP. Again, this won't help incident response and could cause high false positive rates. But what if we say we're looking for specific permissions based on the errors or the API, the method name called, and then we're using that in context with the user in a time and saying we're only looking for a specific threshold? Here we could barely see any results, right? We see multiple bad results. The reason for this is because we actually had 0.13% of this good detection, and we also found a scanning of permissions actually with this idea. Now, again, these are just ideas to spark your mind. How could you use error codes for specific detections or incident response playbooks? So now let's talk about how you could implement this in your environment, right? Start by mapping your codes into your systems. You're using them as fields. Don't keep them as that, structure on the side. Try baselining callers and their errors. Does this entity cause a lot of errors? Is there a spike? Is there no spike? use baselining and all the relevant techniques, and try to stitch the operation IDs so you won't miss any entities. So our key takeaways from this small section is that we could use these for telemetry. The structure of AIP 193 gives us a better way for parsing these errors and detections, and we could reduce false positives. As a summary, we noticed that if we look at error codes differently, we could have a bit more value. We learned gRPC is part of GCP. We learned the flow of a request, the structures of an error code, HTTP status codes, a bit about the long operations, and how we could implement this for detections and investigations. But what now? Tomorrow, start looking at your environment, tag those error codes. In a week from now, conduct an incident response playbook using these error codes. And in a month, write some error-based detections for your GCP environment. But if there's one thing I could have you all take away from today is, if you catch the clouds no, we could prevent the attackers go. Thank you very much. I was Gavriel Fried.
All right, thank you very much, Gabriel. Again, we have a thread in our Slack channel, so anybody remotely or here who has any questions, please feel free to leave them. If you're here and want to ask them live, just go ahead and raise your hand. I'll get started by asking a question of, how would you want Google to, for example, change their error codes, error messages, structure them differently to make it easier to build these kinds of detections? And how do you think about applying that to our own first-party applications that our in-house teams build?
Yeah, so thanks, and it's a great question. I think the way Google currently builds their error codes is inherently way better than I've seen at least in other places, and you could use them easily to parse based on different structures, like for example, when using PySpark. But AIP 193 that we've seen has been constantly going through changes. Like the last update's been on 2024. So Google seems to be right on it, especially because gRPC as a protocol is open source and very driven by the community. They had a whole, I think it was a 10-year event a while back, and they had a whole conference for it. So it keeps on going. And how could we use them in our systems is something I mentioned. Try to take them out of that box of the error code, right? We have this in many different vendors. Also, like in Azure, you have the code and the message, but it depends on where it was logged. Try taking them out as different fields when you're parsing stuff to make them A, more fast, and B, more critical and visible for your eye, because they could sometimes get lost through a bunch of data.
Thank you. Any other questions from the room or Slack? All right, with that, one more round of applause for Gabriel, please.